participant joining us from my name is Sabaskaran Adiwarman and I'm delighted to welcome you to the fourth International Youth Conference on Engineering Innovation and International Student Competition on Engineering and Entrepreneurship ISCENT 2024. We are thrilled to have you with us today, joining virtually to celebrate this prestigious gathering dedicated to advancing engineering, innovation, and entrepreneurship. Today, we are honored by the presence of distinguished speakers who support and inspire our academic community. Allow me to extend a warm welcome to Professor Engineer Hadi Wisriono, SPMT PhD, IPU Asian Engineering, Vice Dean for Academic Affairs, Dr. Engineering Engineer in Brady, Richard Nico SPM Engineering Practice, Vice Dean for Skill and Human Resource Affairs, Engineer Ismu Rini Dwi Ari, MT PhD, Vice Dean for Student Affairs, Alumni and Student Entrepreneurship, Dr. Engineering Engineer Harry Santoso, SPMT IPM, the esteemed Dean of the Faculty of Engineering at Universitas Brawijaya. Thank you, Professor Hadi, Dr. Engineering Engineer I. Indradi, Engineer Ismu, and Dr. Engineering Engineer Harry Santosa. Let's give him a big round of virtual applause. We are also privileged to have the dedicated chair of this event, IYCEI and ISCENT 2024, Engineer Anggara Wiono with Saputra, MTech, IPM Asian Engineering, PhD, who has worked tirelessly to make this event a success. His vision and dedication have brought us all together in the spirit of innovation and collaboration. Thank you, Engineer Anggara, for your commitment to IYCEI and ISCENT 2024. To our distinguished keynote speaker, panelists, and participant joining us from various corners the globe the globe, we extend our heartfelt gratitude for your contribution. Your insight and dedication make this event a beacon of knowledge and inspiration. Let us officially begin this event with a moment unity and pride. Please raise for the national anthem, Indonesia. Indonesia Raya. Thank you everyone for that inspiring start to our event. Now it's time to hear from the backbone of this conference and ISCENT 2024, the organizing committee. Their hard work and dedication have made this gathering possible, and we're incredibly grateful for their effort. to share insight into the preparation, highlight, and what we can look forward for to during this event. I would like to invite Insura Anggara Wiono with Saputra MTech IPM ASEAN Engineering PhD to deliver the committee report. Let's give him a warm round of virtual applause as he takes the stage. Mr. Anggara, the screen is yours.
Okay, thank you for the master of the ceremony of this event. The Honorable, the Dean of Engineering Faculty, University Brawijaya, Professor Hedi Suyono, the Honorable all Vice Dean and all Head of Department of on Faculty of Engineering, University of Brawijaya, to all distinguished keynote speakers, Dr. Tomoyuki Hirano, Dr. Pavon Kumar Asurvijay Kumar, Dr. Jai Feng Yao, Dr. Muhammad Jumain Jalil, and Dr. Debrina P. Andriani, and all honored guests, esteemed panelists, and all the young innovators. In this moment, I am grateful for the opportunity to present the committee report of the 4th International Yacht Conference of the Engineering Innovation. In today's rapidly evolving world, technology is reshaping every aspect of our lives. How we communicate, learn, work, and even the way we connect with the world around us. This extraordinary pace of innovations bring both opportunities and challenges, making it crucial for us to adapt thoughtfully and responsibility. To address these developments, we must first enhance a mindset of continuous learning as the technology advances, so to master our knowledge and our skills. To address this issue, the 4th International Yacht Conference on Engineering Innovation Conference have 8 main topics, and allow me to summarize the key insight from each topics. The first topic is sustainable construction practices. To address sustainability construction practices, our committee explore ways to reduce environmental impacts in the construction sector. It was agreed that the future construction projects should integrate sustainable method to enhance ecological and economic benefit to communities worldwide. The second topic, mechanical engineering research and application. To discuss research and application emphasize advancement that should revolutionize various industries, from improving manufacturing process in sustainable transportation solution. And the third, IoT and electronical engineering as the potential to streamline operations across sectors such as healthcare, agriculture, and logistics. We conclude that prioritizing security, interoperability, and inclusivity to crucial to maximizing the benefit of IoT advancement. And after that, some topics are water quality and treatment technologies, sustainability architecture and green buildings, smart city and urban resilience, supply chain management optimization, and the last is chemical engineering research and development. This year, we are proud to announce that we have received a record-breaking around 335 submissions from talented young researchers and professionals worldwide. This overwhelming response speaks volumes about the commitment of YAT toward addressing global challenges and finding innovative solutions in diverse fields. Furthermore, we are thrilled to have received participants from over 5 countries, including Malaysia, Swiss, and China, and other countries. Each region has brought unique perspective and insights, creating an enriching experience for us. The wide geographical representation, reflect the diversity and inclusivity that this conference values, reminding us that solutions to today's challenge are truly universal and unique global collaboration. With 335 papers accepted for this presentation, we have had the privilege to witness inspiring discussion and exchange that challenge conventional thinking and promote new ideas. The quality and depth of research presented are a testament for the hard work, intelligence, and creativity of the youth across the globe. It's clear that the next generation is well equipped and passionate about driving meaningful change. On behalf of the organizing committee, I extend my deep gratitude to its author, reviewer, and enthusiastic attendance participant. Your contribution have not only enriched the conference, but have also built a foundation for the future collaborations. We also thank our esteemed panelists and keynote speakers for their invaluable insight and guidance. Okay, let us continue to pass boundaries, innovative responsibility, and collaborate toward the solution our world urgently needs. Thank you very much for your kind attention and participation. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you very much for Mr. Angara that highlight the record-breaking of this IYCEI 2024 that for the submission received over 5 countries with 355 paper. So note it is our privilege to welcome Professor Engineer Hadi Suyono STMT PhD IPO ASEAN Engineering, the esteemed Dean of the Faculty Engineering at Universitas Brawijaya, delivered the opening speech for the 4th International Youth Conference on Engineering Innovation (IYCEI) and International Student Competition on Engineering and Entrepreneurship ISCENT 2024. Prof. Hadi, thank you for your unwavering dedication and vision. We're eager to hear your thoughts and insight as we embark on this event. Without any further ado, please join me in welcoming Professor Insinyur Hadi Suyono to the virtual stage with a warm round of applause. Prof. Hadi Suyono, the stage are yours.
Yeah, thank you, Brother Adi Warman as MC. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen, and honorable my colleague, all the vice deans, and all head department on Faculty of Engineering Brawijaya, and then the chairman of the committee, Dr. Anggara Wiono Saputra, and then also I would like to say welcome to all our distinct keynote speakers, Dr. Eng Tomoyuki Hirano from Hiroshima University, Japan, and then Dr. Pavan Kumar Asur Vijay Kumar from Technical University of Vienna, Austria, and then Dr. Yafeng Yao from University of Aeronautics and Astronautic, China, and then Dr. Muhammad Jumain Jalil from University Technology Mara, Malaysia, and then the last one is Dr. Debrina Andriani from the Universitas Brawijaya, Indonesia. Also, the distinguished guests and all presenters and participants. On behalf of the Faculty of Engineering, Universitas Brawijaya, it is my pleasure to welcome you all to the 4th International Youth Conference on Engineering Innovation, IYCEI 2024, and the first International Student Competitions on Engineering and Entrepreneurship ISCENT 2024, which is hosted by Faculty of Engineering, Universitas Brawijaya. As the one of leading university, Universitas Brawijaya has a goal to becoming a world-class university. We achieve this goal through the university vision, that is to become an excellent university with the international standard and able to play an active role in nation building through the process of education, research, and community services. Concerning this, our university implements various academic policies, one of which is the international conference and international competitions. Distinguished ladies and gentlemen, IYCE conference actually covers its knowledge field of engineering. It's become a part of the scientific activity programs in the Faculty of Engineering, Universitas Brawijaya, and play a very strategic and active role in producing a close link to industry and society. In addition to the fourth, IYCEI will also include the inaugural ISCENT 2024. This competition is designed as a platform to bring together talented students from various countries, allowing them to showcase their creativity, technical expertise, and innovative skill. It is hoped that through this IYCEI, the collaboration and cooperation among all participants can be maintained and improved both nationally and internationally. This conference will able to building of a productive dialogue between the participants of different background, especially will be attended by the brightest student to the network and discuss the research. It also provides an invaluable opportunity for the networking and will bring out the welfare of the Indonesian society. And of course, we hope for the first ISCENT is anticipated not only to strengthen students' entrepreneurial and innovative capacities, but also to increase recognition for our students at the international level. I greatly appreciate the whole team which has been involved in this IYCEI and ISCENT events. Thank for all the hard work you put into organizing this conference and competition. Please also allow me to extend the sincere thanks to all our honors keynote speakers. Dr. Eng Tomoyoki Hirano, and then Dr. Pravan Kumar Asur, Dr. Jafeng Yao, Dr. Muhammad Jumain Jalil, and then the last one, Dr. Debrina Andriani. Last but not least, this conference could not have been realized without contribution of all authors and participants. Great appreciation to them. Finally, I wish all participants successful and fruitful conference, and please always keep healthy and happy. And then finally, by saying Bismillahirrahmanirrahim, the fourth International Youth Conference and on Engineering Innovation IYCEI 2024, and the first International Student Competition on Engineering and Entrepreneurship ISCENT 2024 is officially open. Thank you very much for your kind attention, and Assalamualaikum warahmatullahi wabarakatuh, and good morning. Terima kasih, Mas Adi.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the Dean for the inspiring speech that opened this event, the Fourth International Youth Conference on Engineering Innovation and International Student Competition on Engineering and Entrepreneurship. So, ladies and gentlemen, we would like now to capture this special occasion with a group photo. Kindly turn on your camera as we commemorate this moment together. So yeah, the all participants can turn on the camera for the photograph.
First page. Okay, please keep a smile because we don't know where will you be at. We have like 4 pages here. And to all participants, please turn on your camera. Okay, second page. 1, 2, 3. Okay, keep smiling, yeah? Okay, third page. 1, 2, 3. Okay, last page. 1, 2, 3. Okay, thank you. Okay, thank you for the time. We go back to the MC.
Okay. Thank you everyone for the smile. With that wonderful start to our event, we are now ready to dive into the heart of International Youth Conference on Engineering Innovation and ISCENT 2024. We are honored to have a lineup of esteemed keynote speakers who will share their expertise and insight covering a range of innovative topics that push the boundaries of engineering. For our first keynote session, we are delighted to introduce Dr. Engineering Tomoyuki Hirano from Hiroshima University, Japan. Dr. Hirano will present on the topic flame technology for particle synthesis. The session will be followed by a Q&A session, allowing participants to engage with Dr. Hirano and gain deeper insight into his research. Without further ado, please welcome Dr. Tomoyuki Hirano. Dr. Tomoyuki Hirano, the place is yours with your moderator.
Hello. Do you hear me?
Yes, sir, I can hear
Yes, yes.
How about my slide? Can you?
Yeah,
Yes.
we all can see your slide.
Okay. So thank you very much for your introductions. My name is Tomoyuki Hirano. I'm from the Hiroshima University in Japan. So today I want to talk about the frame technologies of the particle synthesis. As we know that the combustion dates back to the beginning of human civilizations and can be seen in the remnant of the numerous artwork, combustion technology is still used today for a variety of technologies. Currently, many commercial nanoparticles products are made by flame metal process, including carbon black, gamma silica, and pigmentary titania. Actually, the frame technology used for the industrial scale production of the carbon black historically, but recently many people use this kind of the frame technology for production of the functional nanomaterials from the first the nanoparticles, and then now we can easy to get the single atom catalyst and then porous particles and the core shell particle also, and then surprisingly we can get also the directly devices, not only the sensors and then nanocomposite film and then batteries. And then now in my laboratory, now I'm focusing the chemical engineering in frames. So as you know, this kind of a frame technologies for the particle synthesis include many chemical engineering topics, and then also the combustion science, like not only the particle technology, fluid dynamics, heat transfer, and mass transfer and reaction engineering, and also the combustion science, and then there's so many kind of the frame reactions, and then spray techniques also. And here, I want to talk about especially frame synthesis of the nanostructured particles in frames. The frame technologies has been widely used because of its high temperature reaction field, continuous synthesis, and then easy scale up. recently it has shown the potential as a direct fabrication techniques for the gases and thin film batteries. And I think one of the most important unit operation in flame technologies is combustion process. To date, a variety of frames have been used for all kinds of applications as shown here. In this, the tubular frame is a new type of the frame that has recently have been shown to be useful as a reaction heat source in particle synthesis. Tubular frame is a tube-shaped frame formed in a rotating flow, and it has many advantages. For example, the temperature distribution in tubular frame is homogeneous and really controllable. And that this kind of the tubular shape is easy to use for the many kind of the systems. Tubular frame is new, not new, but it's really original because this shape is really simple, and then combustion hot gas was keep in the inside the tube. The tubular frame can be get easy just introducing the premixture in the rotating flow. So after this kind of a rotating flow, we can get a really high temperature field in the tube. This tubular frame has some interesting characteristic first because of the axis symmetric temperature distribution. Heat loss behind the frame can be negligible, and thus the almost adiabatic frame temperature can be achieved. This means the tubular frame is thermally stable. Second, this frame consists of the outer arm burst region and the inner burned gas region. The outer region is a high density, while inner region is low density, and the flow is rotating. This is an aerodynamically stable conditions. Finally, and this is the most important part, the unburned cold gas cover the hot burn gas. Hence, the burner wall is kept at a low temperature and undamaged. This is allows for long hour operations. This is very important from the practical point of view. So this time I want to talk about this kind of really controllable frames for the particle synthesis, because many people think the frame is not homogeneous, and then we cannot know the temperature in each part of the frames, but we can achieve the controllable and then really homogeneous temperature distribution in the tubular frame. So now I focus to use this kind of tubular frame for the particle synthesis. So this time I want to introduce this kind of system. And in this work, we try to produce a fine particles by using the control of the inner hot gas region of the tubular frames, the effect of the frame structure, equivalence ratio, and then carrier gas flow rate on the crystal structure and morphologies of the frame-made particles were investigated. And then the experimental conditions are here. The equivalence ratio is defined as a ratio of the actual fuel and air ratio to the stoichiometric equivalent. When the phi, the equivalence ratio, is greater than 1, it represents process with excess fuel. And when phi is less than 1, it represents a process with excess oxygen. We control the value of the phi by adjusting the flow rate of the air and fixing the methane flow rate. This is the tubular frame burner using the study. And then this burner is made of the duralumin, and then combustion tube is made of the quartz for the observation from the frame appearance. when the combustion mixture is tangentially injected into the burner and ignited, a frame of the tubular shape can be established. Flame assisted spray power system has three main parts. For example, the nebulizer and the burner and the particle collector. The ultrasonic nebulizer was used for the forming precursor droplet, and then the fine particles were formed from the ammonium paratungstate solutions in the tubular flame burner. The tubular flame was formed by methane and air premixture combustions. The resulting particles, that's prepared particles, were collected in the bag filter. First, we compare the tubular flame and the conventional Bunsen frame. As shown in this figure, the tubular flame can supply heat the particles in the frame due to its frame structure. To compare the morphologies of the particles synthesized by a tubular frame and the premixed conventional burner 003 particles were synthesized with the premixed Bunsen frame under the same condition as the frame burner setup. As you can see, the 003 nanoparticles could be obtained by using the tubular flame. These results show the sufficient energy was supplied to the precursor in tubular flame. But the Bunsen frame made 003 particles range from the submicron meter to the nanometer range size. Because there was no mixing gases and then considerable heat loss from the system, it's insufficient energy was supplied to the precursor in conventional frame. And then one of the interesting properties of the tubular frame is a controllable combustion, so that we can control the combustion gas compositions using the tubular frame. This is a composition of the burn gas. The composition of the burn gas is the most critical parameter in the flame synthesis of the fine particles. And first, I examine the concentration of the CO and then oxygen in the burn gas at the exit of the tubular flame burner. The oxygen fraction of the burn gas region of the tubular flame considerably decreases with increasing the phi. The oxygen concentration are around 1,500 ppm and then almost zero at the phi equal to 1.0 and then more than the 1 respectively. Moreover, the CO concentrations exceed 25,000 ppm under the fuel-rich conditions. This clearly indicates that the reductive and the ultra-low oxygen atmosphere can be achieved in the burn gas regions during the fuel-rich tubular flames conditions. Furthermore, the experimentally obtained the CO and the oxygen concentrations are in the excellent agreement with the calculated. The dot line was calculation from the calculations. This is a really excellent agreement with the calculated equivalent values. This indicates that these concentrations can be conveniently predicted using the chemical equilibrium compositions. These gaseous conditions are considered to be the ideal for the synthesizing metal particles in the flame because of this low concentration of oxygen concentration can be made non-oxide metal nanoparticles in the flame. It's really good properties for because the flame is just oxide reaction, combustion reaction, so that's why it is easy to get the oxide. But by changing the flame conditions, we can achieve the low concentration of the oxygen atmosphere, indicating that we can get the metal non-oxide particles in flames. Next, we try to make the we try to get the effect of the pi value on the nanoparticle synthesis. Here, the excited patterns of the tubular frame made the tungsten oxide nanoparticles obtained using the equivalence ratio from the 0.88 from the 1.25. This is a fuel-lean conditions. And then this is a fuel-rich conditions, meaning the low oxidation conditions. From the excited result, the particles prepared at 0.88 contain the monoclinic 003 phases. Combustion at phi equals 0.88 occurs under oxygen excess conditions, fuel-lean conditions. This results in the formation of the 003 by thermal decomposition of the precursors, ATP, ammonium paratungstate. At the 1.0 to the 1.12, patterns representing 2.72 and the metallic tungsten also appeared in the addition to the 003 patterns. Although the combustion at these conditions, phi equals 1.25 occurs under oxygen-rich conditions, but only the 003 phases appeared. This is because tubular flame combustions was not realized like this at phi equals 1.25, as you can see in this photograph. Next, we investigated the effect of the carrier gas flow rate on the crystal structures. The carrier gas flow rate was adjusted in the 0.1 to the 0.05 square per meter per hour range at the constant equivalence ratio of the 1.12 to promote the reductions. The excited patterns of the particles prepared at 0.1 indicate the presence of the mixture of the 0.03, 0.2.72 phases. Therefore, the reaction and then we can find the interestingly intensity of the tungsten pattern increases with a decrease in the carrier gas flow rate, and the further decrease in to the 0.05. The result in the disappearance of the 003 and then 002.72 phases. Therefore, the reduction of the product is presumably promoted by the fuel-rich conditions in the tubular flame burner with a low carrier gas flow rate. This slide shows an effect of the carrier gas flow rate on the particle morphologies. At high carrier gas flow rate, at 0.1, after the nebulized droplet contained the ATP precursor were introduced into the flame zone, the solvent evaporation and thermal decomposition occurs instantaneously. And then some micrometer-sized particles were formed like this. And then carrier gas decreased to the 0.08, the particle residence time inside the framing increased, indicating the longer exposure of the energy for the submicron-sized particles, which subsequently partially vaporized, resulting in the formation of nano-sized particles. As a result, the submicron-sized 003 particles were produced together with the nanoparticles. When the carrier gas flow rate was further decreased, the submicron size was completely vaporized. Consequently, the submicron sized particles disappeared and only the nanoparticles were produced. To further investigate the morphologies of morphologies and the crystal structures on the tungsten nanoparticles, we analyzed the nanoparticles. The nanoparticles are near the 650 degrees Celsius. The primary particle sizes are in the range of the 5 to 10 nanometers with a narrow particle size distributions. And these nanoparticles have a center next structures due to the frame high temperature. From the HRTM images of the same nanoparticles, the tubular frame made tungsten nanoparticles have a homogeneous orientations with the interference spacing of the 0.22 nanometers. These values can be associated with the spacing value of the 100 plane of the tungsten crystal structures. Like this, here the summary, I want to say that tube frame is controllable by using the tubular frame system. By using the tubular frame system, we can control the particle synthesis system, and then we can control the many kind of the property of the nanoparticles in frames. So we have more small time, so that I want to introduce other topic also in short. The next topic is fuel cell researches. As you know, the fuel cell is the most important technologies for the next generations science. So that's why. But current situations, the durability of the current fuel cell catalyst is not enough. So that's why we need to develop the new catalyst for the polymer electrolyte fuel cell systems. The fuel cell consists that kind of a platinum carbon nanoparticles in cells, but this kind of the platinum nanoparticle easy to dissolve in the conditions of the fuel cell conditions, and then because of this kind of the carbon collisions, the platinum was agglomerated. So that's why after that the performance of the platinum was decreased. So that in our laboratory, we try to develop the oxide-based catalyst for the polymer electrolyte fuel cells. We developed the platinum-loaded, not carbon, niobium-doptein oxide nanoparticles. The niobium-doptein oxide nanoparticles have a electrical conductivity and a high thermal and potential stability. And then this kind of the chain-like structures is very similar to the carbon. But one of the problems with this kind of the nanoparticles support for the platinum, the density is really high. So that's why the most important point of the gas diffusion in the catalyst sphere is really low. So the development of the porosity in the catalyst layer is really crucial in the development of the oxide-based catalyst support. In the previous researches, we tried to make the porosity in the catalyst using the annealing treatment, just annealing. By just annealing treatment, we can get this necking in between the nanoparticles. So by these kind of necking structures, we can make the porosity in the catalyst here. This porosity can enhance the performance because due to the low resistance of the gas diffusions. But for further improvement of the porosity and the performance, we try to use the macroporous particles for making the porosity engineering of the platinum NTO catalyst layer. If we use the nanoparticles for the catalyst layer, the density is really high. So that's why the densely packed catalyst layer was produced. But I assume that if we use the porous NTO particles, we can get a high porosity catalyst layers. The experimental setup is really, I use a really interesting system because we first make the nanoparticles using the frames preparators, using the frames, because these network structures in NTO particles was useful for this kind of the electrode catalyst. And then again, we disperse these frame-made nanoparticles again into the solution and then treat it again in the diffusion frame with the template materials. These template act as a template materials, PMMA, which act as a template of the pores that we can get the pores in particles. No time. This is the final particles of the final macroporous particles using the frame sphere process. We can get a really clear big pores and then small pore between the nanoparticles. And then this is the catalyst layers. This is from the catalyst layer from the nanoparticles. As you can see, the really dense structures. But when we use the aggregate particles and then porous particles, you can see the clear pores in the cross section of the catalyst. We use the FIB SEM technologies to get the cross-sectional images of the catalyst here using the macroporous particles. You can clearly see the high porosity of the catalyst layer inside the catalyst layer. This kind of high porosity can act can be used to improve the gas diffusion improve the gas diffusion resistance. And then in this final, by using the porous particles, and then we can get a really high performance of the fuel cell. So in my opinion, the development of the new materials is also important, but also just control the structure also important, and then the productivity is also important. We can use frame technologies for getting the particles in the industrial scale, and also we can precise control of the particles also using frames. Thank you very much for your listening. That's all.
Okay, we are now, thank you for Dr. Tomoyuki Hirano. So we are now move to the Q&A session that all participants have question for Dr. Tomoyuki Hirano. You can raise hand and give their question to the Dr. Tomoyuki Hirano. Please, or the participant will raise your hand on virtual and Zoom to give a question for Dr. Tomoyuki Hirano. Once again, to all participants that have a question for Dr. Tomoyuki Hirano, you can raise your hand on virtual on Zoom. Okay, Dr. Hirano, is there any question from Maferel Nurhadi to Dr. Hirano? What are the challenges you face in researching your flame technology? That is the question from Maferel Nurhadi from Mechanical Engineering Department.
Oh, thank you very much for the questions. The frankly speaking, that I already told you the frame technology is really industrial scalable, but as you know, the general frame was bound hydrocarbon, so that's why the many CO2 was produced. So that's why the new combustion technology is needed, but not using the hydrocarbon like the ammonia of the hydrogen or something. But really a few number of the frame technology for the particle synthesis using the fuel ammonia and the fuel hydrogens. So that's why if we can make the same frame technology using the ammonia frame and then hydrogen frame, it's more with that, in my opinion.
Okay, thank you very much, Dr. Tomoyuki Hirano. There's still a time for this Q&A session. So all of the participants, you can give a question to Dr. Tomoyuki Hirano that discuss about flame technology for particle synthesis. So is there any question from the participant to Dr. Tomoyuki Hirano, the keynote speaker, section 1? Okay, there's a question from the participant. What are the advantages of the flame technology compared to the other aerosol technologies such as spraying pyrolysis? For Dr. Tomoyuki Hirano, thank you.
Yes, actually we can get almost same things using the frame technologies and the other spray pyrolysis also. But the most important different point is just heat source. That we use the frames for the spray pyrolysis, frame assisted spray pyrolysis. Because general aerosol process and then frame spray pyrolysis with use the furnace or hot gas. But by using the frames, we can get the really good frame temperature distributions, like the high temperature distribution, temperature changing. This kind of the temperature gradient, we can make the different materials compared to the spray pyrolysis, like sub-stable material or something, or really small particles or something like this. This is one of the advantages compared to the other spray pyrolysis aerosol method.
Okay, thank you very much for Dr. Tomoyuki Hirano for the answering the question from the participant. So yeah, we move to the keynote session. Thank you, Dr. Hirano, for that fascinating session. Now we are thrilled to move into our second keynote session featuring an equally captivating topic. Thank you very much, Dr. Tomoyuki Hirano.
Thank you very much.
For this session, we have the honor. I'm so sorry. For the Dr. Tomoyuki Hirano, there's a certificate for you. Then we have to take the documentation of the certificate. We'll give it to you. Dr. Tomoyuki Hirano, you still there?
Hi. Yes.
Okay, we are give you the certificate for the keynote speaker of this IYCEI 2024. So we are taking the documentation for this session.
Thank you.
Okay, we are taking the documentation.
Thank you. I'm honored to
Hi.
be done.
Can you look at the camera, please? Okay, one smile. Hi. 1, 2, 3, cheese. Okay, thank you very much. ありがとうございます。
ありがとうございます。
Arigatou gozaimasu. Thank you very much, Dr. Tomoyuki Hirano. Okay, we are now moved to our second keynote session featuring an equally captivating topic. For this session, we have the honor of welcoming Dr. Jiafeng Yao, PhD, from Nanjing University of Aeronautics and Astronautics, China. Dr. Yao will present his
Yeah, can
groundbreaking
you hear
research
me?
on electrical impedance tomography for level 3 measurement of cell liquid phase separation, a truly innovative approach with potential implications across various scientific and medical fields. Dr. Jiafeng, he is the associate professor at Mechatronic Engineering College of Mechanical and Electrical Engineering, Nanjing University of Aeronautic and Astronautic, China. The Scopus 8 index, it's 19. Research interest is electrical impedance tomography, microfluid, multi-phase flow measurement. Today's topic is electrical impedance tomography for level 3 measurement of cell liquid phase separation. Dr. Jiafeng,
Yeah, thank you.
the
Thank you,
stage is
Dr.
yours.
Woman. Thank you for your
Thank you
introduction.
very much.
Can you hear me and the screen is okay?
Yeah, that's clear, sir. I can hear you and I can see the screen, sir.
Okay, I will start.
Okay, thank you,
Thanks,
sir.
thanks for Dr. Woman. It's a very good conference. And also I'm very glad to introduce our study. So my topic focused on the electrical impedance tomography, and we also applied this technique to measure the cell and other tissues. So my presentation includes 5 parts. So firstly, I want to introduce the concept of liquid-liquid phase separation. As we know, this time, Dr. Haslinda and me, we all, our research are focused on the multi-phase flow. That means the solid, gas, or others. But more detailed, we can call another phenomenon. We call the liquid phase separation. It's not a multi-phase, but it's because of the viscosity of the liquid, the multi-components mixtures will separate into different phases under certain conditions. And inside the cell, we know the initial phase separation with cells allows specific molecules to aggregate and subsequently from a specific reaction zone in the complex intracellular environment. We call the membraneless organelles. That means this inner some proteins without there's no membrane. So this formation I can use experiment to explain. For example, you see the red side if we add a droplet of oil in the water, we can see that this is a phenomenon of liquid-liquid phase separation. So the studying of this liquid-liquid separation is very important to study the some incurable diseases. For example, Alzheimer's disease, Parkinson's disease, and cancer. So in our research, we want to use a real-time level-free visualization method to detect the process of LLPS. We can call the liquid-liquid phase separation as LLPS. So the traditional method, we need to use labels to label the protein. But in our research, we want to propose a label-free method to monitor the process of the phase separation inside the cell. So if we can monitor the process, we can study the study the incurable diseases. So this is our purpose. So as for the electrical impedance, I will introduce some background. We can call it as EIT. As we know, before 1990s, the very traditional imaging method we can call the X-ray or ultrasonography, like this. This is a physical imaging. With the development from 1990s to 1920, 2020, there's the digital imaging method. It developed very quickly, and also until now, we also face new challenges. That means how to detect the body use functional imaging. That means we need to detect some disease at the very early stage. And we want to use wearable and portable sensors. So the EIT method, that means our method is a very proper method to realize the wearable and portable. And also it is a functional imaging method. So in order to explain easily, we can compare it with the CT method. You know, the traditional CT, when we go to a hospital, we need to scan our body by using CT. That CT uses the X-ray, so it has a radiation. But for the EIT, it's a new imaging method we call the EIT. Compared with the CT, it has a real-time, functional, portable, and no radiation. This is the advantages. But the disadvantage of EIT is the low resolution. So our research purpose is to improve the resolution of EIT. So I want to introduce the principle. You see, if we arrange 8 electrodes around the object, we can get an electric field. For electrode number 1 and number 2, we can inject a current, so it generates an electric field. And then we will scan other pairs of electrodes. You see, we can get the pair 2, 3, pair 3, 4, and then we get the voltage of the around the object. For example, this is the banana and the cucumber. If the cucumber didn't insert the banana, we can get electric field. If it insert the cucumber, we can get a change of the voltages around this object. So we use the change of the voltage to calculate the distribution of the conductivities in the area. So finally, we use different colors to label the different conductivities so the objects can be found. So this is a simple principle. So we use this principle. We developed the hardware and the software. This is the hardware we developed, and this is the software. and also we applied this device to many applications. Now we have developed these devices, and also the image is, we can call it as a real time, because we realized 40 frames per second. So it's a very quick velocity. So it's applicable to biomeasurement. You see, this is a font term in our lab. This is the font term in our lab. So in the middle image is our device, and this is some other font terms in the lab. So as you know, we have applied this EID method to several applications, such as cell measurement, lung imaging. When we breathe, we can get a real-time image of the lung, and we can also take the measure the muscle and bladder. So in today's presentation, I focus on the cell measurement and also introduce other applications briefly. So for the cell measurement, a problem we want to consider why a cell can be detected by the electrical impedance method. So we establish a equivalent circuit model. So for a single cell, the cell membrane behaves like a capacitor, and the inner of the cells and outside the cells, it behaves like a resistor. So for these characteristics, we can establish we call the equivalent circuit model for the cell, and then if we get the model, we can use the electrical impedance method to scan the cells, and then we get the different cells will generate different electrical signals. So this is the basic principle. We measure the cells. You see, in our experiment setup, we need a cell solution. Also, we need a syringe pump to inject the cell mixtures into the microfluidics. And also we developed a microfluidics like this. In the microfluidics sensors, we can see around the cells, there are also, we developed 16 electrodes. We use 16 electrodes to detect the electrical field around the cells and the inner cells, so we can get reconstruct images of the cells. So this is a microfluidic chip, and also we use a data analysis setup. We use a LCR meter, and also we use a data acquisition system. And finally, we can get a series of data from the cell. And when just now I introduced the how to measure a cell, but you know this topic is to detect the phase separation. That means, for example, like oil, how to separate the oil with the water. So we need a filter. So we also use microfluidics to generate phantoms, such as, for example, is here. We use a very small injector, and we generate micro droplets around by oils. You see the water and oil mixture here. And then if we change the temperature or add some more and more oils, the process will be changed. So in our experiment, we want to detect the process of the liquid phase separation process. So this is a phantom. In the left side is a process. Sorry, is in Chinese. So firstly, we use a microfluidic. You see, put the cells, use the injector, the syringe pump, injects the cells in the center of the electrode, and then we can inject the current and measure the voltage change. And finally, we use the EIT algorithm to reconstruct the images. So the protein in the cells change, we can capture the change. And finally, we also use some AI algorithms such as deep learning or convolutional neural network. So this is a simulation method. So we established a simulation model. We use free energy and diffusion equations and free energy functional, and also the classical CH equation. So we get this is a simulation of the process of phase separation. So in the right side, we can use the EIT to reconstruct the phase separation process. So this is a simulation. And then we also establish experimental setup. Experiment. So you see, we use the oil and the water because it has a different viscosity. So we add a droplet of oil in the water. So with the increase of the oil, the phase separation can be detected. So this is the first line is the phantom. We can see some drop of the oils. If we add more and more oils, the oil will aggregate together and becomes a very large droplet. So we use the EIT method to reconstruct the process. You can see this is the experimental results. And finally, actually, we also this result is a little different. It's not a phase-to-phase separation, but we firstly detect a single cell by using our microfluidics and the EIT method. You know, the cell diameter is only 20 micrometers. So this is the smallest. This is the smallest cell we detect in the literature. So we know the research in Edinburgh University, they also use the EIT method, but their diameter is 1 millimeter. But in our experiment, we realized the most very smaller cells, it's only 20 micrometers. So in the next study, we will use this setup to realize the phase separation inside of the cells. So this is the next study. And also, we know the EIT is a very good method, I think portable, real time. So we also will apply this technique to other applications. The first application is to detect the tongue tumor. You know, in the hospital, the doctor want to cut the cancer in the tongue, so it's difficult to find the boundary. The traditional method is to add some liquid and use the CT. So it's very complex. So we developed a planar electrode array, like a stamp. So we stamp in the tongue, and we can get the boundary of the cancer. So this is a application we have realized. So we also develop a BIST method. This means bioimpedance spectroscopy tomography method. That means we combine the EIT method and the spectroscopy method to get the image of the boundary of the cancer. So this is our results. You can see in other applications for the cancer, we get several clinical samples And then we use our EIT sensors to get the signals. You see, this is a we use a yellow color to circle the cancers. So this is the result. We can see in the near the cancer, the red circle in this, the T is the tumor. Is the impedance is high. So until now, we get many clinical results. We found that the tumor has a very high impedance. And for another tumor is we can call the we use the endoscope for the tumor analysis in the stomach. So if we insert the stomach, and then we need to cut the cancers and then get the results by using the other method. But in our method, before we cut the cancer, we can scan this part, the cancer, and to confirm if it's not a cancer, and then we cut. So it's a release and relax and release the doctor's work. So this is a very, I think it's a very good method, and also it has a very high novelty. Eh, before we insert the stomach, also use a soft robot. We combine the soft robot and then combine to the sensors by EIT. And next application is for the lung imaging. We can see we also develop the hardware and also we get a commercialized device. So if we breathe, we can get these colors. The blue color means the lung breathes very well. And then we get some curves and to get quantitative data. So this is the lung imaging. In the real applications, we also developed the 3D EIT. Also, this result has a very high novelty. That means we only get one belt. Actually, one belt can only get one cross section. But in our algorithm, we establish a very broad electrical field. That means use one belt and get the whole lung. We can get a 3D image. You can see. Now also this 3D EIT, we also improved the calculation method. We can get a real time over 3D. So this is the results. And for the medical hospital applications, we get a patient we call the pneumothorax. That means in the left, you see this is the left lung. That image is opposite for the real because we use a scanning method. It's a same direction of the CT with CT. So that means the large area is the right. This is the right lung. This is the left lung. You see this patient, the top of the left lung has some problem. It cannot breathe. So we detect this this problem, and during his staying in the hospital, he recovered. So we can detect this process. So this is a application. Another application is we call the chronic obstructive pulmonary disease. That means it cannot breathe fluently. So the traditional method, we use a pulmonary function instrument. So this is a traditional method, but for the old people, it cannot breathe, it cannot blow this instrument. It needs large, it's difficult to blow. But for our method, it's not necessary to blow for the patient. We can detect the image of the lung. We can find this in the hospital, it can become better and better. So white color means it breathes more and more better. This is our results. And also, very interesting application is for the newborn baby. We know the newborn baby in the lung, it has a lot of water, so he likes cry. When he cry, he feels very good because he changed the air into the lung. So in the hospital, is no, we don't have a good method to detect this process. That means when a new baby born, we cannot get an image of his lung, but by using our EIT method, we can get an image of the lung for the new baby. So this is a very interesting applications. And finally, we have applied this EIT device, commercialized device for many hospitals. So I listed several top hospitals in my slides. For example, the first affiliated hospital of Jinan University, and also the Beijing Xie Hospital. Also, this is the top hospitals in China. You see, this is in a hospital for lung imaging, and this is the doctors, and also this is a newborn baby here. And this is a certificate of medical device. As we know, the medical device is different from the industrial devices. So we need to get the certificate. It's very difficult. But if we get the certificate, that means we can commercialize this device. So several days ago, some friends from Indonesia, Gajah Mada University, we also discussed if we can apply our device to Indonesia hospital, in the Indonesia hospitals. So if professors or doctors are interested in our device, also we can discuss more after the conference. So this is our lab members. We have 5 members, and Dr. Sun and Dr. Ye, they also graduate from Chiba University in Japan. So now they joined our lab, so we're in the same lab. So in future, we will collaborate more and more researchers to develop our EIT method and develop more and more potential applications in hospitals. So that's all. Thank you. Can you hear me?
Yes, sir. Please kindly wait for a moment, sir.
Okay.
Okay, we'll move to the Q&A session for Dr. Jiafeng Yao, PhD. So there is any question from the participant, you can raise your hand to give a question for Dr. Jiafeng Yao, PhD. Okay, there's a question from Mafaran Rohadi to Mr. Jiafeng. Mr. Jiafeng, does the method of electrical impedance tomography bring an effect to the cell itself, i.e. change on the cell's characteristic? Thank you for the thought-provoking presentation beforehand.
You mean if we apply the electrode to the cells, can the electric field affect the function of the cells?
Yes, sir.
Okay, I will answer because the electric my answer is it cannot affect the function of the cells because the electric we only use 0.1 milliampere, so it's very small electric. So the current is very small, so it cannot influence. But you know, we know the cells. If we applied strong electric field, it also can generate other forces. For example, the Joule heating and for the dielectric force and other forces will be generated. So in our experiment, we use a very low current. Yeah, this is my answer.
Okay, is it enough from Mafarel Nurhadi? Okay, thanks for the response, sir. The second question is what are the key challenges in achieving high resolution imaging in electrical impedance tomography, and how do advancement in algorithm and hardware address this issue? There's a question from the participants. Sir.
Okay, thank you. Actually, the key point of the EIT technique is image reconstruction algorithm. We know we only get 16 electrode voltages, but we need to calculate the conductivity distribution in the area. So it's a yield, or we call it yieldness method of inverse problem. So in order to improve the resolution, we need to improve our algorithm. For example, we use AI algorithm, deep learning, CNN, to improve the resolution. It's in basic, if we want to improve the resolution, we need to improve the algorithm. So this is important. And so also for the hardware, the key point is to avoid the noise. You see, the electric field is generated, and around the environment, if there are some electric field or magnetic field, it will influence the image. So we need to use some noise filter or some other method to avoid the noise to influence the hardware. So this is key important. The noise is a key important. How to decrease the noise is a key point for the hardware.
Okay, thank you very much for the response, Dr. Yao. And now, thank you very much, Dr. Yao, for the insightful presentation and the engaging Q&A session. So we'll move to the documentation. We give you the certificate for the glad for being the keynote speaker.
Thank you.
So we take the documentation first.
Okay, can you watch the camera, please? Okay, give us a big smile. 1、2、3。OK，哎，谢谢。
Thank you. Thank you.
Thank you very much, sir. So, ladies and gentlemen, we're now ready to begin the parallel session 1, where our presenter will have the opportunity to showcase their research in smaller, interactive breakout room. Each presenter will discuss their submit article, engage in thought-provoking discussion, and receive valuable feedback from participants and panelists. Presenter, if you're scheduled for an upcoming time slot, please locate your assigned breakout room as indicated by the organizing committee. If your presentation slot is scheduled later in the session, feel free to remain in the main room until it's time to present. During this time, you can also enjoy the simultaneous keynote session 3 happening here in the main room. So, ladies and gentlemen, uh, make sure the name is in accordance with the format to make it easier for the committee to remind you that is your schedule for presenting. So we move to the keynote session 3. Ladies and gentlemen, it's time to shift gear as we dive into our third keynote session. We are excited to welcome a speaker who is not only a pioneer in their field, but also bring a wealth of knowledge and perspective to the topic of sustainable practice in engineering. Prepare yourself for enlightening experience as we hear from Dr. Junain Jalil from University of Technology, Mara, Malaysia. Dr. Jalil will be presenting on sustainable approach for oil epoxidation. So we can read the background of Dr. Muhammad Jalil, Jumain Jalil.
Okay, sure. I will share my slide first.
Okay.
Okay.
I have the background of the Dr. Jumain Jalil is he is the associate professor at Chemical Engineering Studies, College of Engineering, University of Technology, Mara, Malaysia. Scopus H index is 13. Research interest is biomass conversion, renewable energy, polymerization, biocatalyst, and today's topic, Dr. Muhammad Jumain Jalil brings a sustainable approach of for oil epoxidation. Thank you very much. So, Dr. Muhammad Jumain Jalil, the time is yours to be a keynote speaker.
Okay, thank you very much to the organizer. By the way, you can look my slide. Is it clear? My sounds?
Yeah, it's
okay.
clear.
Okay, good. Okay, first of all, thank you for the community to inviting me to sharing on the knowledge regarding on my research, especially on a sustainable approach for epoxidation of palm streets. Okay, I have been honored to share my knowledge regarding on the palm stearin. As we know that palm stearin one of the product from the palm oil. So it's quite suitable for the Malaysian and Indonesia because we are the most the second and the first exporter in the world for the palm oil productions. So let me introduce a little bit myself. My name is Muhammad Jumain Jalil. I come from Faculty of Chemical Engineering in UiTM. So I need to share my slide first. Sorry. Okay. So my research area regarding on the biomass conversion, biopolyol, catalyst activity, renewable energy, and as well as kinetic modeling. As just said before this, I come from University of Mara. When University of Mara located in Shah Alam, Selangor, Kuala Lumpur, and was one of the community of University of Mara. So my presentation outlines today little bit on the introduction, what is an epoxidation process. So from there, what we do and what motivates us to conduct this research, explain as well our research methodology and some of my results and discussion regarding on our research. And last but not least is some conclusion and our recommendations. Sorry. Okay, so how about the background of the research? What is a palm sterins? Palm sterins, Scaro research has focused on developing more environmental friendly method for producing polyol from vegetable oils. Nowadays, for information, polyol was produced from petroleum base. However, as we know that petroleum will be depleted sooner or later. So in this research, we substitute petroleum base into the vegetable base. And our focus today is a production of IYCEI palm sterins, where palm sterins one of the product come up with the palm oil is due to renewability and higher content of unsaturated fat we make readily available at lower cost. So for your information, the palm stearin, they have a what we call this fatty acid composition. We can categorize into unsaturated and saturated fatty acids. Since palm stearin contain around 40% of unsaturated fatty acids, it can be converted into the IYCEI process. So the depletion goal crude oil reserve rising cost and strictly environmental restrictions. So in this this motivated us to study and conduct a research to substitute use by to fully utilize palm sterins. Palm stearin also we can categorize as a byproduct of palm oil. That's why in this study, we are focusing on using a raw material palm sterins. So palm sterins is to produce our main product is epoxidized palm sterins with highest hydroxy value, or we can categorize we can name is a hydroxylated palm stearin or polyol via hydroxylation process. So in this research, our research objective is to formulate a new product from epoxidized palm sterins. As for information, epoxidized vegetable oils was mainly produced nowadays. It's not only come from palm oil, but also other vegetable oils such as soybean oil, sunflowers, coconut oil, and others. Since epoxidized vegetable oils very active and unstable product, we intend to be a ring opening to produce a variety of chemical. We can simplify that epoxidized vegetable oil can be as a chemical precursor. So what are the significance of this research? To the first one, to make it a low value to the higher value product. As mentioned before this, palm sterins can be categorized as a byproduct to produce palm oil. So in this research, we expect to increase the price of palm sterins because we produce variety of chemicals from palm sterins. The second one is produce high quality hydroxylated palm stearin is anticipated to be produced because the polyol production from epoxidized vegetable oils was mainly depend on the hydroxyl value. The highest hydroxyl value is tend to be highest more quality product. Okay, and the third one is valuable to future research seeking to investigate the physicochemical properties of epoxidized palm stearin as well as hydrogenated palm sterins. So our product was investigate their physicochemical properties to ensure they meet what is called industry demand and so on. And by doing the research, we also study and investigate the thermodynamic and kinetic data that have a potential to enhance the overall design of the reactor. Since our research mainly based on the what is called laboratory works, so the expect the future study to develop our new plant to produce hydroxylated palm sterins. So, palm sterines, our main renewable sources was contains unsaturated fatty acid and saturated fatty acids. While the unsaturated fatty acid, for example, oleic acid contain 26%, while for the linoleic acid contain 5.5%. So from the figure, from the picture and the table, we clearly cut that palm sterine contains highest unsaturated fatty acid that can be converted into the epoxidized product. So hardest component of palm oil is palm sterines, and limited use due to high melting points, while palm sterine have a limited use nowadays because they have high melting points due to its classification as a byproduct, and it's a lower cost and has considerable potential to be used as a fat supply. That's why we want to convert from the low value added product into the added value product by utilize the palm sterines. Malaysia and Indonesia is rich of palm oil, which is widely recognized for the cost effectiveness compared to other vegetable out there. That's why in this research, we only focus on the palm oil and their derivative. Okay, what is epoxidation? Epoxidation is a double bond is converted into the epoxide, which is a simplest form of cycle atom. So in this study, we react with palm sterine with perfluoroacetic acid to form epoxidized palm sterines, and the byproduct is acetic acid. This is called an in situ epoxidation process, where during the epoxidation, the nucleophilic reaction occur on the double bond of the alkane by electrophilic species, result in the formation of epoxides. The ion pair of the oxygen atom from peroxide acid, and then after we get epoxidized palm sterines, we can add into alcohol or water to produce hydroxylated palm sterines. Our decision is called a polyol product. They have two type of agent for the ring opening of epoxide palm sterine, which is water of alcohol. In this study, we use both hybrid alcohol and water to produce polyol. Multiple nuclear attack to the carbon atom in the oxygen ring, we make more shorter time and thus require purification of epoxide. Okay, as mentioned before this, epoxide very active compound and acts as a chemical intermediate product. That's why in this study, epoxide can be react with others reaction to come out with the final product. For example, epoxide will react with water to produce polyol. Same with methanol. How about hydrogen peroxide with react with hydrogen peroxide to become a PU, polyurethane, and others. So our research methodology, first from the raw material palm sterine, we conduct optimization of process parameter to produce epoxidized palm sterines, and we further our experiment, our research to produce hydroxylated palm sterine. So we can conclude that basically from the palm sterine, we can produce two type of product, which are epoxide palm sterine as well as hydroxylated palm sterine. So this is making it more clear. It's a simplified reaction mechanism of epoxidation as well as a ring opening of epoxidation. First, we add hydrogen peroxide. We add hydrogen peroxide and formic acid to form performic acid. And then performic acid, we react with the palm sterine to produce epoxidized palm oleic acid. Since oleic acid, they have palm stearin have a fatty acid composition is one of the largest fatty acid composition is oleic acid.
Oh, udah ada Faiz coy.
So then epoxide palm oleic acid we react with water or alcohol to produce polyol. So this is a schematic diagram. We only involve a chemical reaction between hydroperoxide, formic acid, and the part one of the catalyst is sulfuric acid to speed up the process. And then we produce epoxide oleic acid. And then after we produce epoxidized oleic acid, we add to the methanol to produce hydrogenated palm stearin or polyol. So the expected from the experiment when we produce epoxide oleic acid at the highest speed of relative conversion of zero, relative conversion to ozone, we adding the water or alcohol to produce hydrogenated palm stearins. So now we look for one of the some of the result and discussion regarding on our experimental methods. First, as mentioned before this, we in this research we mainly focusing on the optimization process to produce high quality of epoxidized palm stearin as well as hydrogenated palm stearin. So we only apply some of the Taguchi method to get the best optimum condition. For example, what are the best temperature, molar ratio for the acetic acid, molar ratio of hydrogen peroxides, what are the best optimum temperature for the steering speed and pressure. So after we get the best operation condition, we analyze by using a FTIR to make sure that our raw material palm stearin was fully converted into the epoxide palm stearins. So based on this result, we can clearly show that palm stearin can be produced to produce epoxidized palm stearins as well as hydrogenated palm stearins. So based on our research activity, we can conclude that they have a potential to be published in high impact journal since our research was starting and at 2014 until now. So we do a lot of research R&D, for example, to substitute the type of catalyst, to use more renewable catalyst, to use more, for example, waste cooking oil, to substitute raw material, use more green chemical and so on. So apart of that, our research was published in high quality index, high impact journal, as well as was involved in some of the patents and innovation competitions. So based on my presentation, we conclude that the maximum epoxide yield which was produced is 65%. And palm stearin was successfully converted into the epoxide and hydrogenated palm oil. And the recommendation for the next experiment or next research is to develop a kinetic model to make sure that a good agreement between simulation and experimental data. I think that's all for my presentations.
Okay, thank you very much from presentation from Dr. Jalil. What an incredible presentation, Dr. Jalil. Maybe we have to move to the Q&A session. So the all participants can give a question for Dr. Jalil about the sustainable approach for oil oxidation. So the participant who can raise your hand and virtual on Zoom to give a question for Dr. Jalil. So, Dr. Jalil, the first question is, what are the main challenges in developing sustainable methods for oil epoxidation, and how can they be addressed? Because uh, many experiments are about the oil epoxidation. It's very hard. It's very, very hard about the oil epoxidation, like palm oil, EPO, like EPO epoxidized palm oil. It's very hard. And uh, from you, what is the main challenge about the oil epoxidation? Thank you.
Okay, thank you for the question. For to answer this question, I refer to based on my experience, the most challenging to conduct epoxidation process is in a safety and safety in the safety term. It means that we use a lot of acids, for example, hydrogen peroxide, formic acid, sulfuric acid. So to make sure that we conduct in the safe condition, the first regulation is that we must follow the spec of safety to make sure that they have no what is called accident during the experiment. The first one, and the second one in terms of to get the highest quality or purity, to get the highest purity of epoxide yield, since epoxides are very what is called active, and as an intermediate product, we very hard to get highest purity. For example, to production of epoxides pump syringe, we only get the maximum yield around 30%. So because only unsaturated fatty acid contained in pump syringe only around 30%. That's why I think the most challenges is to get the highest quality of our product itself.
Okay, thank you very much, Dr. Jalil. So the second question coming from the participant is Mr. Rama Octavian that raised hand before.
Okay, thank you so much for Dr. Jumain for your very nice presentation. So, I don't know, maybe I missed for your presentation. Do you need some catalyst for your epoxidation reaction? And then, what type of catalyst that is required for the epoxidation reactions? Is there any criteria for some materials or for uh, to be able to become a catalyst in your epoxidation? And then my second question is there any chance for you to increase or to enhance the yield of the epoxidation reactions? Probably you adjust the operating condition like temperature, pressure of the reactor, so that you can obtain a higher yield or maybe a higher product with higher purity or higher conversion. I don't know. Yeah, that's all my question. Thank you.
Okay. Thank you for the question. For the first question, in this study, we only using a conventional catalyst, which is a sulfuric acid. As we know that sulfuric acid, the highest acid catalyst that can enhance the process. However, our team also studied the hybrid catalyst between acid catalyst and solid catalyst, since we know that the sulfuric acid very corrosive, can be corrosive to our equipment itself. But then we come up with the impregnation of catalyst, which is a combination of zeolite and into the sulfuric acid. We call the impregnation of catalyst. For the second question, what is called how to increase the yield of the product. As we know that a pump syringe only contain around 30% of unsaturated fatty acids. So of course, the yield may be around 40% and not above 80%. Then our next, maybe our not next our planning or something like our research team conduct is to hybrid between pure oleic acid and pump syringe. As we know that pure oleic acid contain around 80% of unsaturated fatty acids, so we can combine with pump syringe to get more quality and highest the yield of the product. Okay, I think that's all for the
Yeah,
questions.
yeah, very clear to me. Thank you.
Welcome.
Thank you, Mr. Rama. Now, we from the committee will give a certificate to the keynote speaker as a form of appreciation and pride in being able to collaborate to make this event a success. So we have to take documentation, Dr. Jalil.
Okay, can you give a smile? 1, 2, oops, sorry. 1, 2, 3. Okay, thank you very much.
Okay, thank you, welcome.
Thank you very much, Dr. Jalil, for bringing us the best presentation about the sustainable approach for oil epoxidation. So we have to move to the keynote, our fourth keynote session. Let's
Opo.
keep that momentum going as we move into our fourth keynote session. We're thrilled to welcome an exceptional scholar and thought leader who is here to illuminate the intersection of management science and strategic decision making. Get ready to expand your understanding of how pricing and investment decision can be influenced by cutting edge management principles. Please join me in giving a warm virtual welcome to Dr. Debrina Andriani from Universitas Brawijaya, Indonesia. Dr. Andriani will be presenting pricing and investment decision with management science, a topic that is not only timely but also crucial for aspiring engineer and entrepreneur. Dr. Dr. Debrina Andriani, PhD, assistant is a assistant professor at Industrial Engineering Department, Faculty of Engineering, Universitas Brawijaya, Indonesia. The Scopus Index the Dr. Debrina Andriani is 5. Research interest is about the decision analysis, engineering economic, game theory, and today's topic, Dr. Debrina will bring us a good presentation about the pricing and investment decision with management science. So, Dr. Debrina, the seats are yours.
Okay, thank you. Please wait a minute. I will share my screen. Is it clear enough?
Yeah, that's clear. I can see the screen.
Okay. Wait. Well, thank you very much for the MC for the introduction. Good morning, everyone, and thank you for the opportunity today. My name is Debrina Puspita Andriani from the Department of Industrial Engineering, Faculty of Engineering, Universitas Brawijaya. I'm honored to present my research entitled Pricing and Investment Decision with Management Science. To be honest, this presentation is part of my doctoral dissertation. It was published in the Alexandria Engineering Journal, some of journal with OSSGI and SGRQ1. Thankfully, right now I'm working on several research projects on topics that are still related to my doctoral background, either sponsored by the faculty, university, or Ministry of Higher Education. However, since all my research conducted this year is still in progress, I think it would be better to present the results that have gone through the peer review process. So I hope with the little knowledge and experience that I share, I can open up opportunity for networking and research collaboration in the future. Let's start with the outline. We will go in 5 parts: introduction, literature review, problem description and assumption, model development and analysis, computational result and discussion, and finally, let's wrap up in a summary and future research direction. In the introduction, I present briefly the background and motivation behind the research and explain the objective of understanding strategic pricing decision in a competitive business environment. Last, I will show the scope and framework of this study. So as we know, in modern business, quality is an important part of science. However, adopting quality-based strategy can increase product quality and customer demand, but often requires substantial investment costs. The manufacturer is typically responsible for producing quality product, while investing in quality might benefit other supply chain members. And furthermore, considering the real market condition, it's widely recognized that warranty also signal the quality. So similar to the manufacturer who consider investing in product quality, the retailer also consider offering after-sale service to promote the manufactured product and increase its profit, such as providing the warranty. In spite of signaling quality, offering the extended warranty also incurs a substantial cost and increase the price of products sold. Therefore, I examine an investment strategy in which a manufacturer produce a product with quality and a retailer increase its profit by offering warranty to the customer by constructing a two-level supply chain. Due to the interrelationship between quality and warranty, both the manufacturer and retailer need to carefully consider the decision, including the pricing strategy. At the same time, I realized that there are several power structures in the market that can affect the decision-making sequence and finally the supply chain profit. So in general, we know that there are three power structure models are developed in GEM theoretical model, one kind of method in management science. That's why I put the title management science in this presentation. This model includes the centralized, manufacturer-led decentralized, and retailer-led decentralized. Therefore, we extended our investigation by considering the power structure in two-level supply chain that already constructed. Anyway, despite the growing body of the literature on the impact of pricing decision in supply chain management, examining the specific effect of this decision under different power structure is still necessary. To this end, there are 5 research questions that guide our investigation. And for example, maybe I will take one. The first one is, how do supply chain members determine optimal pricing decision and maximize profit in the competitive supply chain? By five objectives, we can generate theoretical and managerial implication for optimal pricing decision and investment strategy. I also outlined the scope of this study in the following framework. After finish with an introduction and literature review, I will describe the problem and assumption, constructed the model development, and then perform the numerical and sensitivity analysis, and propose a coordination contract analysis. And finally, I make summary for this research. Moving on to the literature review, I extensively analyze existing theory and study related to pricing decision and supply chain. In short, I divided this part into several research streams in pricing, investment strategy, supply chain power structure, and any others. I identify the gap in the most related existing literature to position my research as shown in the table. From this table, previous work have yet to discuss several issues in the research stream that I already listed. To fulfill this gap, this study develops supply chain model concerning all those situations. So from this literature review, now we can discuss the problem description and assumption. This study focuses on pricing decision in the context of investment strategy under power structure. Firstly, I examine 2-echelon supply chain with a single manufacturer and a single retailer. A manufacturer invests in manufacturing innovation technology to improve the product quality level. And at the same time, a retailer invests in after-sale service with an extended warranty. For illustration, Toyota, one of the largest automotive manufacturers, built quality improvement year after year in the automobile industry by focusing on the quality manufacturing system. However, due to quality and reliability issue, Toyota dealer or third party offer extended warranty service to attain competitiveness and improve customer satisfaction. Therefore, it's critical to determine whether it is worth it, such as product reliability, maintenance costs, and extended warranty length. And in here, the retailer market the product to customer in different segment customer. We set two customer segment, the actual and the potential customer, to represent the heterogeneous customer demand. I consider the initial size for actual customer, while the potential customer will be affected with the quality level, warranty length, and also price. From this setting, I generate the demand function and profit for the whole supply chain and also its member, manufacturer and retailer. So we can see here, we focus for the customer demand, including the actual customer and also the potential customer demand. And then we can get the manufacturer profit, retailer profit, and the whole supply chain profit. Next, I will show you the model development and analysis in this study. So I developed decision-making model considering the power structure to achieve supply chain coordination. There are centralized, manufacturer-led decentralized, and retailer-led decentralized decision-making model. For each model, I verify the model concavity using linear algebra and determine the optimal decision, as we can see in the table. In the centralized model, a manufacturer and retailer specify the joint decision to maximize the whole supply chain profit. Centralized is an ideal model, however, it's challenging to achieve practically. In real market, the decentralized model is broader applied than the centralized. In this setting, its member in the supply chain will maximize their own profit. By applying the manufacturer-led decentralized model, the power structure difference will be occurs. Therefore, there are leader and follower in this model. So we used Stackelberg game and backward induction to solve the game and determine the optimal decision in the decentralized model. By using this formula, we can continue in the subsequent to computational result and discussion. Based on this result, we can generate the managerial insight. So to verify the previous model we built, I performed numerical analysis by selecting several relevant parameters regarding the literature review. And we first examined the effect of optimal decision on total profit for the whole supply chain and its member with the decision-making model under power structure. From this table, we can see the optimal price, quality, investment level, and the extended warranty length are the highest under the centralized model compared to both the decentralized, either manufacturer or retailer. Furthermore, the centralized model always has higher profit than the decentralized model. Meanwhile, the power structure affects its member profit when they do not coordinate. For example, in manufacturer-led decentralized model, the manufacturer profit is more significant than the retailer. And also for the retailer-led, the retailer profit is higher than the manufacturer-led. This finding address or investigation of the power structure impact on supply chain operation. Therefore, I present all of this theoretical analysis in corollary 4.1 to 4.5. Since two decentralized models have lower profit than centralized, we can conclude that the coordination is not achieved in here. So I propose coordination contract to achieve win-win situation for this study. However, before we go to the coordination contract, I want to show the effect of other key parameter on the decision variable under different decision-making model. I investigate the initial market size coefficient alpha as it represents the estimate initial market size for actual customer, the quality investment level coefficient beta that denotes the sensitivity of the investment level made by the manufacturer to produce a quality product, and last, the extended warranty length coefficient theta indicate the sensitivity of the extended warranty length offered by a provider to sell its product. From all of the parameters, actually they positively correlate with the decision variable in all decision-making model, either the price, the warranty length, or profit. We present the theoretical analysis in proposition 4.1 to 4.2. And we also demonstrate this analysis graphically. As an example, this figure shows the effect of the initial market size coefficient, alpha, on optimal profit under different scenarios. Increasing the initial market size coefficient, alpha, under any model will increase the profit. In turn, it will also increase the customer demand and all decision variable for warranty length, price, extended warranty length, and the other. At the same level as the initial market size coefficient alpha, we can see the centralized model C consistently outperform both in the decentralized model. From this analysis, we can understand that increasing the initial market size coefficient for actual customer can support the manufacturer and retailer to achieve more demand and profit. Therefore, the manufacturer and the retailer should strive to fulfill the customer demand and maintain the customer loyalty. The same situation also occurs for the other parameter, beta and theta. So let's move to discuss the coordination contract. In order to coordinate the supply chain power structure, we propose two wholesale price coordination contract under power structure, a manufacturer-led and a retailer-led. As the manufacturer and retailer typically deal in wholesale order quantity, we propose a wholesale price contract where the pricing is determined on the wholesale order quantity rather than per item. The supply chain member accept a contract where one the member compensate other member. So, for example, under the manufacturer-led, a manufacturer profit compensation index X to the retailer to coordinate after sales. In this setting, I assume the wholesale price equal to the selling price. And we also use the same formula to get the retailer-led wholesale price. I summarize the contract analysis in corollary 4.6 and 4.7 and show the interval of compensation index for each contract to achieve the coordination and win-win solution. By performing the numerical analysis, we clearly recognize that within the interval of X and Y, its profit for the whole supply chain of the coordination contract model has been achieved the same as the centralized model. So moreover, the manufacturer and retailer increase more than profit in the decentralized one. To better understanding the impact of the compensation index on the profit and the wholesale and its member, I illustrate the right-hand side figure, and we can observe increasing compensation index for X and Y tends to increase profit for the retailer and decrease profit for the manufacturer. Therefore, the decision maker will determine the compensation index X and Y from the bargaining power of the manufacturer and the retailer. Finally, managerial insights are generated. Longer retailer warranty period increase the warranty costs, but can increase the manufacturer profit. Therefore, interdependent decision and higher profit motivate a member to cooperate with the other continually. And this study confirmed that the wholesale price contract under power structure effectively coordinate and achieve a win-win situation. And as we near to the end of the presentation, I will share a summary of my key findings from the previous discussion, and I will present a comprehensive overview of the implication and outline the potential future research direction in the field of the pricing decision. Okay. From the summary, the first one is in pricing and investment decision, the whole supply chain outperform under centralized than a decentralized model. Therefore, we propose with a coordination contract, and the total profit of two decentralized model have achieved the same point with the centralized model. An increase in initial market size, quality investment, and warranty length coefficient has an increasing effect on the optimal decision variable and also performance, which is profit. And our study also has several theoretical and practical implications. For example, in theoretical implication, this study contributes to enriching game theory model for decision making in supply chain. And meanwhile, the practical implication of this study can assist the manager and decision maker determining optimal pricing decision to maximize profits and satisfy customer needs. We acknowledge some limitation of our study. So to overcome the limitation, we propose some interesting topic for future work. First, future study can expand by examining a more comprehensive coverage of power structure and the consequence of this structure on pricing and investment decision. And the second one, utilizing empirical data can validate and obtain a more comprehensive understanding of this finding. And the last one, integrating this study with other theory, such as behavioral economic, is worth exploring the more complex decision in supply chain. This is the list reference I use in my research. By understanding the factor that influence pricing strategy, we hope that business can make informed decision to gain a competitive advantage in the market competition. Thank you for your attention. Now I return it back to the MC.
Okay, thank you very much for the presentation, for the great presentation from Dr. Andriani. So we'll now move to the Q&A session. For all participants that have a question for Dr. Andriani, will kindly raise your hand and give the question to Dr. Andriani as a keynote speaker. Patient 4. Okay, for the first question, how can management science technique enhance the accuracy of pricing strategy in not stable or volatile market?
Okay, thank you for the question. So since our research is focuses on building the simulation strategy, therefore I propose we need to validate using the empirical data. Right now, we still build the model and we still have to validate using the data that we get from the primary data. And for the question about the volatile situation, we try to focus on what kind of parameter in sensitivity analysis. So by sensitivity analysis, we can obtain the result about the stability of economic due to the change of some parameters. Is it answer your question?
Yeah, thank you very much for Dr. Andriani. Maybe one more question from the participant. You can raise your hand or give the question for Dr. Andriani. Yeah, there is a question to ask to Dr. Andriani again. The second question is how the viral behavioral economic principle intersect with management science and shaping pricing strategy.
Okay, thank you very much for the question. Yeah. About the behavioral science, how can it interact with our discipline, especially management science? Actually, it's provided in my second paper. Yeah, I tried to combine behavioral science using the customer utility So we know how about the customer satisfaction and also about the customer experience. And I try to measure the utility from the customer, which is, will the customer buy our product or not if we offer more length warranty? Maybe you can find the other paper. Actually, I still confused which one I should provide, but before we start this presentation, I already promised to the committee, Dr. Mara, that I will use this title. So maybe later, if someone who want to contact me, you can reach me on my email, debrina@ubi.ac.id. Thank you.
Okay, thank you very much, Dr. Andriani. So we're now move to the committee will give a certificate to the keynote speaker, Dr. Andriani, as a form of appreciation and pride in being able to collaborate to make this event a success. Thank you very much for Dr. Andriani. We have to take the documentation first.
Okay, can you please give us a big smile? Okay, 1, 2, 3. Cakak. Okay, thank you very much.
Thank you.
Thank you very much, Dr. Andriani, for bring us a great presentation. Let's raise our virtual applause to Dr. Debrina Andriani as the great presentation that would bring in this conference. So yeah, right now we move to the quiz competition. Ladies and gentlemen, as we transition into the quiz competition, I'd like to inform you that the quiz will be taking place in the breakout room. If you're participating in the quiz, please make your way to your assigned breakout room as indicated by the organizing committee. For those of you in the main room, you can take a moment to stretch and recharge. We encourage you to discuss the conference highlight with a fellow participant or reflect on the insights shared so far. Please remember to return to the main room by 12:40 as we will kick off keynote session 5 at that time. It's promised to be engaging presentation and we'll love to see everyone back here to continue our exploration and innovative topic. Enjoy your time and we'll see you shortly for the next exciting session. And for the all participants, you can also join to the breakout room to see the presenter, to see the quiz competition. That was very amazing. So thank you. We will see you on 12:40. Enjoy your time.
Raditya Dharma Yuda, please join QR4 breakout room.
Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. As we prepare to kick off our next keynote session, we kindly ask all participants to turn on their camera. Your presence adds to the energy and engagement of our virtual environment, and we want to see your enthusiastic face as we dive into this exciting presentation. Thank you for being a part of this experience and let us create